all before we start? Yes. We will have a test on Wednesday.
Isn't that chapter 4 to 5?
Chapter 3 and 4.
3 and 4.
On Savage.
Savage.
And chapter 2 on the other one, right?
Really?
Is that what I said? Okay. Computer science book is chapter 2. Is that chapter 2 or chapter 3 on computer science?
Chapter
2, right? And chapter 3 and 4 on the other one. I'm going to start chapter 5 today, but it's not going to be in the test.
It's going to be open book like last time.
Yeah, but it's going to be much harder than last time. So we are adding some programming in there. So you're going to be writing some small programs in the test, because some people were doing some things that was not nice. So we have to do it a little differently. Copy and paste. So it's going to be a couple of 2, maybe 3, I don't know, depending how much. You will have less time. So basically what I'm saying is, if you come here and you try to do your reading here, it's not going to happen. You have to be ready to do your stuff. So most of you should have enough time to finish your test on time. So that means you have to study before you come to the test. No, it's going to be maybe 40 minutes, 45 minutes. It's going to be very, very short. You are not going to have time to read your book over here. If you want to look up things, that's fine. But you are not going to have time to go on internet and search stuff, or get your friend on the text messaging and text message your friend, those kind of things that was happening last time. So we're going to have a very, very short time to do it. And if I catch you doing that, I'm not going to even talk about it. You're going to get 0. Basically what I'm trying to say is, if you're copying and pasting your program, you will not pass this class. So you better drop right now, because I have seen some programs that's copy and paste of other people that is not going to cut it for this class. The reason I'm teaching in community college or college level versus high school is I don't want to deal with these things. I don't think it's fair to other people for somebody who doesn't do the work, turn in work from somebody else and get a better grade than the person who is trying very hard. So for that reason, I have to be a little tighter on this. And that's why I'm going to have a programming. I'm going to do it a little harder. It's not that I want to do it that way. It's because of behavior of certain people in this class, which is not correct. So that's the reason I'm doing it. Yes, sir.
So we want to multiple choice.
We will have a multiple choice, and we will have a programming segment to do it.
So multiple choice an hour, and then
No. The whole thing is going to be like 40, 45 minutes.
multiple choice.
Everything. Yes. You will not have time to bring your book here and start sitting over here and study. Right. You can do whatever you want to do in that period of time. I don't know yet. But what I'm going to do is I'm going to take the test myself, and I'm going to double the time for you.
What?
Let's see.
Don't rush it.
Don't rush it. Let's see if I can pass it. Then I raise the time a little higher. No, the idea for this test. The idea for this test is for those who are not doing their assignment or themselves, then they're not going to pass this test. That's the first idea. Second one is, I have found out that if the test is a little harder, people are going to study more. So my concern is to read the book for those who are listening to me. To read the book. Some of you doing, most of you are not doing it. So that's the reason we're having a test.
Can you tell by the program somebody's read it?
Oh yeah. Not only the program, the questions that people ask. The questions that you ask. No, I'm not pointing any finger, but there are some people who are not reading it. I would say a lot of people who are not reading it. Okay? We good? The idea is not to memorize, but remember, when you go to interview, it's not going to be open book interview. They're going to ask you a specific question and you have to answer them, if that's what you want to do. In real life, yes, you have open book, you have open computer, but you never, ever in your work, you're going to go copy somebody else's program and turn it in and say, this is mine. Because not only you're going to fail, the whole company is going to go under. Cheating is not a good thing out there in the industry. If you have been doing your assignments so far, you should be fine. I wouldn't worry about it. Just go over the book, and as far as you know where everything is, you don't have to memorize it. You just need to know where it is so you can look it up. And if you have been doing your assignments so far, I don't think you should have any problem. Any questions? No questions? Okay, so we're gonna do chapter 5 today. So we're going to continue about the functions. Okay, once again, if you want to talk, if you don't want to listen, that's okay. Just step outside so other people are not going to be interrupted in your area, please. All right. So we're talking more about functions. When you were doing chapter 4, some of you were asking, how can I return more than one variable? Because right now you know how to return a variable through the return function. Now we're going to talk about those things. We're going to talk about the void functions called by reference parameters, using procedural abstraction, testing and debugging. General debugging, I'm going to leave it for later on, hopefully Wednesday. But we're going to cover the first 3 section tonight. So first thing, void function. This is going to be the function that is not returning anything. So first we're going to talk about the top-down design. We talked about it before. We take the task, we're going to break it down to the smaller pieces, and that's going to be for our function. And no value, just input or output, for example, or we're going to have one value or more than one value. So, so far we have seen the how to implement function for chapter 4. You have been doing it for your assignments. And that's going to be returning value. So if we put a void, the one that I'm going to be concerned right now is going to be returning no values. I'm not going to be concerned about more than one value. I'm just talking about returning no value. So every time I see a void function, that means it's not returning any values. So the way that we're going to do it, we're going to put the word void. Basically void means nothing. So I can omit this word, or I can put it in there for to see how it's going to work. Okay. So we need it for our declaration on the top. We're going to need it for our definition on the bottom. We're going to call, but we don't need it when we're calling the function. So we need 3 things, right? Declaration, definition, and we're going to call the function. Okay. So this one, you can put this word return here, but basically it's not doing anything. So I can take this return out, I can take this word void out, and it's going to do exactly the same thing. Yes, sir.
So it's just when you have a void function, it's just when you want to see out like the results.
That's a very good question. For the void, it's not returning anything, so a lot of times we're going to be using it for display things. We can use that. And another thing we're going to learn is we're going to be returning some variable through the reference. So the parameters that we're going to use can potentially return a value. So we can take the return through the parameters. But generally that's correct. It's for the display, for the output, those kind of things. Remember, the procedure is what? Input, processing, output. For the input and the output, we can use the void function. and for the processing, we can mix it up. So display 5.1 in your book is looking at some of these void functions that we would have the word void and the braces just like we have. Then we have some parameter list over here. So when we're calling the void function, we don't have to put anything in front of it. So it's just the calling the function, the parameters that we need, we can put it in there, or we can put it, it says we cannot put it here because it doesn't return anything. Because it doesn't have a return, I cannot use the cout on it. It does not have a return. Yes? That's a good question. For me, the way that I am being trained is every function that I have is returning something. Because when I was doing the programming in the C language, the return was our error message. So we would always return something. I have got used to using my return because I can apply something like this. I could return something, I can use my cout, I can assign it. So for my functions, I'm going to be using return value as much as possible. That is my style. So your style can be different. You don't have to go. Who's printing? Okay, would you stop printing, please? That's my style. And we're going to learn about passing by reference. So we can return the value through the parameters. And we talk about those two. So part of these things is going to be your style of how you want to do it. Which one is better than the other one? Where is going to be the functionality? We talk a little more about it. So the functionality is almost the same thing that we had before. We have the argument values are substituted for the formal parameters. That's what we had before. And then we have the statements in the function body are executed. That's a typical way of doing it. And then we can have the word return. Or we can just not do it. So, converting a temperature, this is going to be something like this in your test. That I would give you something like this and ask you to write that function or a program for it. So if I give you an example like this, you should be able to write the code for it. If you don't know how to write the code for this, then we're going to have some serious problem. What is the value of this at all the time? What is this going to return? It's going to return 0 all the time. C, if I have this in my program, C always going to be 0. It's always going to be 0. Why is it that? 5 divided by 9 is 0. 0 multiplied by anything else is also 0. Right. I mean, this is a pseudocode, yes. If you put this one exactly like this, it's not going to work. But the bottom line, yes, if you have to put the multiplication code. But the key here is what? Integer divided by integer does not give you a decimal point. 5 divided by 9 is going to give you 0. 0 multiplied by anything else is going to give you 0. So that's what we have to be careful. And I think we talked about this long enough, that an integer divided by integer is going to return an integer. So that's going to be one of the questions for your multiple choice. Or you can change 5 to 5.0 or 9 to 9.0. Okay, so he's asking if I put the 1.0 at the end of the statement, somewhere around here, if I multiply it by 1.0, is that going to fix the problem, Christiana?
No.
Since you are text messaging, it's going to be your turn. What do you think? So what do you think?
I think it's not going.
It's not going to work.
Yeah, order is
Right.
the first.
Yes. So we got to be careful with the order. Okay, so the typical one, remember I am looking for these comments. You have your declaration, you will have your comments just like that. And then you're going to have your definition on the bottom. Yes? Question?
Okay, so what is this void return will do?
That's a very good question. What is this doing? If you don't know what is it doing by now, we have some serious problems. So if I call this function, which is called initialize the screen, what is going to happen?
Separate the core and output from
Next line.
What this function do? It just see out the and the L. It's just going to return one line. That's it. Blank line.
Using namespace.
Why do you need that then?
Well, it's just showing. I'm not saying you need that, but that's the function. That's all it does. So you can put some other stuff in there. And its explanation is over there. Separates current output from the output of the previous later on program. The reason that we have this namespace here is in case we move this function somewhere else and that function that doesn't have the namespace on the top, we're just going to be using it for this one. Yes? That's not because we are using the iOS stream, we're going to be using this namespace. We're using it for the input output. That's why it's using the namespace for that one only. And it's going to be more portable. So something like that would be a good question for a test. And still I'm getting some program that doesn't have the sample dialog in the bottom. Remember, those are going to be deducted points. I don't know how many times I can repeat that anymore. So this return over here is optional. If you have it or don't have it, doesn't make any difference. Some people like to have it because they got used to having a return. This void over here, you can put it, you can take it off, doesn't matter. Yes, sir.
So, for example, say we want to do a void on the results, we want to take that, put it somewhere else, and then show the results. That's what the void is for, just to preserve it, so we can move
No,
it.
void, the way I'm looking at it, void means nothing. It's nothing. You don't have nothing. You cannot save it, you cannot do anything with it. So for the void means nothing. You don't get anything for it. So if you want to save it, you have to do it some other way.
So why not the void?
That means you're not returning anything. So for example, I give you example. I want to write something on top of my program. Say, what is it my program doing? Do I need to return something with that function? Let's say that I want to, at the end of my program, I want to display my output. Do I need to return anything with that? I'm displaying my output. I don't need to return anything. That's going to be a void function. Those are the examples. Once again, when I was doing it, they were asking us to return the error message. So that's why in your main you're returning 0. Some compiler is going to complain about it if you don't have a return. The newest one, I don't think they're going to have any problem with it. But for me, was always return an integer which will have the error message. No error message is going to be 0. Error number is going to be returning. So that's why when you call into the IT support somewhere in India, they're going to ask you for a number, and then you're going to give them a number, and they have a list, and this number means that function in that program is going to have this issue. Those are all documented. And that's what I usually return with my function. So, why are we using a return? Because sometimes we have the if-else statement. So basically we want to break off in the middle of the function. We don't want to go through the whole thing. we can use the return over there. That way I don't follow all the codes. As soon as I get what I want, I get out. And the last one says void function in display 5.3 avoids division by 0 with return statement. So we're going to look at that. So if I have a 0, I'm not going to go through this because I don't want to divide by 0. I just return. That means this whole thing is nothing is going to happen here. Just like you had a break in your switch statement with the case statement, you had a break. Here you can use the return to stop any section of your function. Remember, in real life, the functions are much longer than what we see here. This is just the short ones to practice for here. So, our main function is going to get smaller and smaller. We're going to be calling only the functions. We're going to create functions and we're going to call functions. We are not going to do anything else beside that. The return 0 typically means that we don't have no error in it. We can just take it off if we want to. These are the ones that I was showing you about the end of these sections. These are going to be some good example of what I was going to be asking for the test. So you should be able to do some of these things. For example, I would be asking this question: describe the difference between the void function and functions in return. Of course, this chapter is not covered in the test. I'm just giving you example of the things that might be in the test. So what's going to happen if you forget the return statement in a void function? Nothing. What is the difference between the void function and function that returns one value? It doesn't return any value. Okay, everything else is the same. It's just not returning anything. Okay, this is the most important part of this chapter. Calling by reference. Okay, so far we have been calling by value. Calling by value means that the computer would make a copy and send it to a function. That means that value or that variable is guaranteed, that's not going to be changed. So when I'm doing a function call, it's going to go inside that function, it's going to do its stuff, and if I change that variable inside the function, nothing is going to happen because we have been passing by value. Now, if we want to return some value, basically we want intentionally change the value of our variable that we are sending it as a parameter. We're going to send it as reference. So calling by reference means we can change the value of it in the function. The good thing about it is what? That we know that we are going to change the value, so we can return 1, 2, 3, 4 variable from a function. The bad thing about it is when I'm doing that, I don't have no idea what's happening with my variable if I want to follow it. So if I have a variable that is going to go through multiple functions, I don't know it has been changed, it hasn't been changed, so debugging is going to be a little harder. So to do that, we're going to use this ampersand. So we can put it next to double or we can put it next to the variable. It doesn't matter. That just shows that we are passing by reference. That means I'm not making a copy of it. I'm just sending the address in the memory. So if I'm using the direct access of the memory, the actual value is going to be changed. So whatever comes in here as a parameter potentially is going to change. I'm saying potentially, that means not necessarily is going to change. It can be changed. Yes, sir.
If you have a function that uses call by reference to change the value in a variable, does that variable have to be defined globally, or does it only need to be in the function that's calling this function?
Okay. We are discouraging anybody to use any global variables. So what's going to happen is you're going to define your variable wherever you want. You're going to call the function with that variable. It does not matter what we're calling it inside the variable. It's going to change it. So I'll show it to you in a minute. That means if I'm calling this get input, I don't have to pass a variable called f variable. I can pass anything I want through it when I'm calling it. So that name has to be defined before I calling it. I'll show it to you in a couple of minutes. Yes?
Didn't you say like void function is not going to return any value?
That's correct.
But in this void, he asks the user to see in variable.
That's correct.
So when I see in, isn't that just putting whatever I see in into the f variables?
That's correct. So it's not returning anything over here. It doesn't return anything over here, but it's going to return it through this variable. So the void function, what we said earlier, is not returning a value. That means we are not getting anything returned by this. But now we are using a return by parameter. That can be done with either this one or the one that you have the return value. So this is my input. Remember, we have input, processing, output. So I can create my input functions that's going to be using this to just read in whatever input that I need. And this ampersand is going to return the value back up. Let's look at some examples on this. So in this case, I have get numbers. I have ampersand, ampersand. That means potentially these two are going to be used. And it's going to be changed. But when I'm calling them, I'm using first num and second num in the main. So this first num and second num has to be defined somewhere. So if I have a cout over here before the get numbers, if I do a cout for first number, second number, what do I get? Before the get number. If I do a cout on first number and second number, what do I get? That's good, because it depends what's going to be in the memory for those. We're going to get some 25,785, something like that. That means that's what is stored in the memory. So that's the reason that we get a habit of setting this to 0. So we're sending those two to what? To this one, get numbers, right? So it's going in with some random numbers here. This is this input 1. The first number becomes input 1. The second number becomes input 2. And because I'm using the ampersand, they're going to be using their memory locations. So now I'm going to ask the user, please enter 2 numbers. And when the user puts, I'm reading this input 1, input 2. Okay, remember this input 1, input 2 came in as first number and second number. So now when I hit this one, what's going to happen? My first number becomes this one. My second number becomes this one. So if I have a cout after this, the values that came in as an input is going to be available. Now I'm going to do the swap value. Swap value is going to do what? We're going to assign a temp. We're going to put variable 1 in temp, variable 2 in variable 1, temp in variable 2. So we switch their place. What are we sending in? First number and second number. So if I have a cout right after this, my second number becomes first number becomes second number. And the last one is show result. It's going to take the first number and second number is going to show result. And you can see I don't have nothing in front of these things because they don't return anything. The parameters have been changed, but the return is nothing. Yes, sir.
Remember, in the computer science, what you saying to create some information, actually not relating those things. You just mark at the memory saying this is variable.
Mhm.
So when I name the integer first num, it just goes to some place this variable, and then when I see out, you just see out whatever.
That's correct.
That address
Whatever it-
used to be at.
Yes, exactly. Yes.
Okay.
That's correct. Or it's going to, yeah, that's correct. It does not, we don't have an eraser in there to go erase it. So whatever was left over from, remember the memory is going to have some stuff in it. So that's what's going to be in there. Yes?
I'm not sure honestly why you need the ampersand. If you did the void get numbers, you have to input 1, input 2, and for the swap values, you did in the definition you swap the values.
Right, but
So
okay.
why would you need?
That's That's a very good question. If I did not have the ampersand over here, they would not go back up. So you would do this, but my first num and second num would not change after this. So if I had a cout over here, and I didn't have the ampersand over here, I still have the junk in there. That is passing by value. It would not change the value of the first num and second num.
Oh, so we want the get numbers to change too.
That's I mean, the value is going to be changed, yes. If I didn't have these ones in here, then after this, I have example. Give me a minute, you're going to see. Okay, so this is the display one. We're getting two of these in. For this one, I don't need to have anything come out. Okay, so I don't have ampersand here. I'm not returning anything. I'm just displaying my outputs. So, when we're calling by reference, it works almost as if the argument variable is substituted for the formal parameter, not the argument's value. So we are not passing a copy of it. We are not passing the value of it. We are using the memory location for it. Okay. Now, in display 5.5 is talking about how is this happening. What did I? Where did you go? Okay, so we have the first number that is sitting in an address of 1010, and we have second number that's sitting in address 1012. In real life, those never happens because our memory is much larger, and the low numbers usually is assigned for the operating system. Operating system is using the low side of the memory. So usually it's about, I don't know, much longer than address. But for now, we're using these things. So if I am calling these first number and second number, then we can use what we'll be saying is we're going to be using it inside the function, and then we're going to look at the outside the function. So we have some display. Remember, if you want to know what your program is going to do, you're going to just do couts in there, and it's going to show you how things are happening. So when we are doing anything, we are not using the value of first num and second num. We're going to go to the memory address of first num and second num, and that's whatever we do in there. And because we're going directly to the memory address, if we change anything in there, the actual value is going to be changed. Something like in global variable that you were thinking about. So if I'm using this ampersand, it's going to act like a global variable that we were thinking earlier. Yes?
Whenever you have the ampersand, you have to define what the variables are in the definition, because there's no variables. There's no number assigned to the variable, so you have to assign the variables in the definition.
No.
Use ampersand.
You're talking about over here?
Like you have the CN inside the definition.
No, no. We're using it over here. We don't define the variables inside. We are putting it right here.
Right.
So the first num and second num is here. We're going to use those things, which can be called different thing if we are calling it. So if I define my first num and second num over here, what's going to happen? I'm going to overwrite what was coming in.
Okay.
So basically, I'm going to reset it.
Okay.
That was actually a good question. If I define it over here, my variables, it's going to reset these things. Just like in the middle of a program, I would define my variable, redefine it.
And if you don't define them, it's just going to be what it's going to be.
Yes. Okay, this is what's happening in there. So I have two functions. One is going to be called by value. The other one is going to be called by reference. If I'm working with the call by reference, I'm using the memory location. So age is in the memory location of 1001. The value of it is 34. If I'm calling by value, it's going to take this 34 and pass it through here. So even though it's going to be changed or anything like that, my 34 is not going to be touched because I'm copying a 34 in here. So this value is never going to change after this is executed. But because I'm using the address for this one, because I have an ampersand, whatever changes is happening here on the age is going to happen over there. So if I change age inside of both of these programs, because this one has an ampersand, it's going to affect this one. Because this one doesn't have an ampersand, it's not going to affect this one. So to be safe, I'm going to try to use the one without the ampersand, passing by value as much as possible. That way I know my variables are not going to be changed. When I need it, then I'm going to be using the call by reference. So that's the time I'm going to, by default, I'm not going to use call by reference as much as possible. Yes?
If you do the ampersand call by reference, but you put it as a constant, would it make it so you can't change it? It will just use the values.
To use it as a constant, why do you want to do that?
Be a global method.
No, like you take a function, you run a function on two variables that are defined by reference, but you set them as constants.
But the whole idea of passing it by reference is that we want to change it inside the function
So by default, we should do it by value.
by value. Let's try that one. I want to see what's going to happen. That did not come to my mind. But using a constant in front of it, you are saying that we don't want to change it. And usually we do that for the array. But for one variable, I never done it. So that actually defeats the purpose of using by reference, which is we want to change the value of that variable. So the swap value is going to be what? We have a temp, we're going to switch it. Now my variable 1 has been changed, my variable 2 has been changed. If I didn't have the ampersand over here, it would not affect my calling site. But because I have the ampersand, now when they're coming in, I could have number 1, number 2 over here. That number 1 and number 2 would be changed. We can mix it up. We don't have to have ampersand all or no ampersand. We can mix it up. We can have an ampersand for one of them, not for the other one, and for the other one. If we want to mix it up, that's fine. So this one is going to return a value, or it's going to change its value. This one will not, and this one will change it. So how do we decide whether a call by reference or call by value? Use a call by reference formal parameter. Excuse me. So if we want to change the value, of course, we're going to be doing it that way. But for me, I always ask if I have only one variable that needs to be changed, or any variable needs to be changed, maybe I'm going to use it for by return value. I am more comfortable returning things with my function, because then I can use my function anywhere I want as a variable by itself. So what's going to happen if I don't put the ampersand? The change is not going to be affected. So if I had a swap values, that's something that somebody asked earlier. If I don't put the ampersand, I'm sending in first num, first 2 on the swap value. Let's say I had 1 and 2 in there, but because I don't have ampersand, it's not going to change it. So it's not going to actually swap it. It's going to swap it inside here, but because I don't have ampersand, it's not going to bring it back into the calling function. Does that make sense for me? Okay. Yes?
Yeah, if you do a constant, even with the ampersand, it still won't change the value.
It won't change the value.
Just compiler error.
Okay. So you get a compiler error.
But could you, in the function, could you change the data type from constant to something else, change it, and then change it back?
No. If it comes in as a parameter, that's the whole purpose of having a constant, because you want to say do not change this one inside the function. Usually you use that for array that's coming up later on. So these are the example of what's going to be in your test. So when you're going back and read your chapter 3 and 4, you've got to consider some of these things for your test. Remember, all these things are being captured, and you have it in Blackboard if you want to go review some of this stuff. Okay, procedural abstraction. So the way that we're going to define our functions are going to be in a way that is like a black box. I don't need to know, or the next person doesn't need to know what is my definition. I have to have enough information for them to know what to do. So we use functions like POW or a square root. I don't need to know the codes inside of it. All I know is the square root is going to return a square root of a number. Or I know the POW is going to do a power. So how does it work inside? I don't need to know. For that reason, I have to have enough comments on the top by declaration to show what we're talking about. Programmers should not need to know the details of the function. We do not give the code to the next programmer. They're just going to be using my function. We can potentially call another function inside another kind of a function. So if I have a swap value function, I can call it in another function. Yes?
Can I put a function at the integer and
If you have a function that has a return value, yes, but in the calling side, not in the definition part.
Why? Don't put it in the definition.
Not in the definition. You can do it later on. You're going to learn how to do it. Right now, I don't want you to do it, because that's going to change the whole concept of what we're doing right now. Remember, in C++, the question is not if we can do it, is how we're going to do it. So it's almost everything that you think about, you can do it in C++. But then the outcome might not be what you think. One of the reasons that I like to have functions with return value is when I'm calling this, I can't call it using my other function as a parameter. So this is another example, the 5.8 that's doing. So remember, as we go along and I talk about these things, I'm going to be looking for it inside your programs. So we have a declaration. We're going to have comments to say what are these about. So can I find out what is this order function means? Orders the numbers in the variables n1 and n2, so that after the function call n1 and 2, what is it? It's going to be less than or equal n2. So we have enough comments to tell the next programmer what is this they're going to be doing. So this is an example of calling another function inside of this function, but this one has to be declared on the top before the other one. So if it goes to do this one, it has to know what it is. So this one has to be on top of this one. Another way of explaining these things is what is it that I need before I call my function? What is going to come up after I'm done with my function? So these are the comments that are expected moving forward. What is a precondition? Variable 1 and variable 2 have been given values. So I have to have some values over here. What is postcondition? The values of variable 1 and variable 2 have been interchanged. So these are all the comments for the new future programmers to come and read these things, and including myself. When I come back to these programs, most of the time it doesn't make sense, because 6 months down the road, I don't remember what I was doing. Yes, sir.
So we need to put precondition and postcondition now.
For a little bit, yes. The bottom line is we need some comments on the declaration to know what's going on. And if we have some condition, we have to put it in there. So the next programmer does not have your definition. They cannot look at your program definition to find out what you're trying to do. So for that Celsius program, we have the precondition that Fahrenheit is a temperature expressed in degrees Fahrenheit, and it's going to return the Celsius. So why are we using this? First of all, it's going to be for the designing. So when I'm designing my functions, I know where I'm going with it. Specify what is a function should do. That's the processing. Remember the input, processing, output. So the processing part is what is it going to be doing, and minimize design errors and minimize time wasted writing code that doesn't match the task at hand. So these are the reasons that we need to have precondition and post conditions. Okay, so we have a case study here. Supermarket pricing. Determine the retail price of an item given a suitable input. 5% markup for if item should sell in a week. 10% markup if the item expected to take more than a week. 5% for up to 7 days. Changes to 10% at 8 days. So we are defining our input, we are defining our output, and we are defining our processing. IPO, input, output, processing. So we're going to break down 2 subtasks. So the subtask on this one, input data, output data, processing part. So we would have at least one input data, we're going to have at least one output, and we have one too many processing section. Each task can be implemented with a function. So our main is just going to be calling those functions. So which one do I need to use call by reference? Which one do I need to call by value? Input data. Do I need call by reference or call by value? By reference, because if I'm inputting data, I want to return it back. Compute the retail price of the item. What about the output result? Do I need to call by reference? Do I want to change anything when I'm displaying things? So, for the price, I am getting the values and I'm passing it by value because I do not want to change the cost and turnover inside the function. I'm just going to return a value double, which is going to be the price. I do not need to use call by reference. The output, same thing. I don't have to do by reference because I'm not going to be changing the cost, turnover, or price. I'm just going to display it. My main is getting smaller and smaller. All I have to do is declare some variable, pass those variables to my functions, and call the functions. So I'm calling 3 functions. The one that has a return value, I'm going to have the equal sign here. So this is my retail price that I'm using over here. If I want to be a little fancy, I can just use this function right here. I can use this function called price whole cost shelf time. We can just put it right here, and it's going to work because that's going to return a value, and that value can be used inside this function. I'm not suggesting to do it, but it is doable. Maybe Ben can do it. You got to see what he's doing. He's writing a program to do some interesting stuff. So we have the pseudocode. We're going to write the pseudocode in an English language type of thing. That remember, up to this point, we are not thinking about the code. When we start thinking about the code, our concentration is how to make it work. We want to design our program. We're going to design our algorithm before we start writing code. So far, I'm not concerned about if my code is going to work or not. I'm just working on the design part. Now that I have my design done, now I can write the code, and it's going to take very short time, and a lot less errors. We are creating some constant. Convention again for the constant is all uppercase. Why do we use constant? Yes.
And those constants are going to come all the way through all the function definitions. If it's out, it'll.
Yes. So we are defining it on top. Later on you'll learn how to create your own pound include, not in this class though. So I would put all the declaration and all the constant in a pound include. So if I put a pound include on top of my program, all of these things going to be on top of my program. Looks like a global variable that you can use it throughout the program. So once again, we're going to have our function declaration with some stuff in it. We have our const over here for now. That's where our constant is going to be there done. And because it's before main, it's going to be visible to everybody. All the functions. So we are using our constant over here. Technically, I could use my constant inside of this function, if that was the case. And once again, the sample dialog box. So how do we test it? In the real life, we're going to ask the customer to give us some sample data to test. We're going to think about the areas that is important to us. So if they say that 7 days is the boundary, I'm going to be checking it above 7 days, less than 7 days. What number can go wrong? So I'm checking my domains over here. What range am I using to see if my program is doing it correctly? So I would do it outside with a calculator or some other ways, and then I test my program against that. So these are sample questions for your test. I'm going to leave the testing and debugging for Wednesday. Any questions?